And we're back for the second piece of Chapter 1. They mentioned, let me get our slide here, reusability. I stopped on reusability in this one, then we'll move on to reliability, maintainability. One of the other goals or one of the other functions of a standard install is, will this be reliable and manageable? Again, do I want my network to be unreliable? No. Again, for yourself, obviously not, but if I'm installing for somebody else, my reputation's on the line. I don't want it to be unreliable. So again, if I install based on my standards, things should, faults on my network should not be, the reason should not be my cabling. It's probably the patch cables or the exposed parts of my physical network, if you will. When I start troubleshooting, I don't immediately start grabbing cable certification meters and scanning cable runs. No. I start at my patch cables and my user and those sorts of things, because that's typically where the faults are. So again, a standards install should be ruling out cabling problems in my network. Next part of the chapter, they move on to the structure of cabling. Okay. First part, they say structured cabling, hierarchical system of wiring structures designed to distribute connectivity from a central point out through intermediate points to workstation locations. Okay. Well, if I look at my home network, this is what I have at home. So let's start with kind of what we know, and we'll build into what we have into a commercial building. What I typically have at home is my workstations and devices connected into my wireless router, if you will. And you notice I drew it this way because it's really, my Linksys or Netgear or Belkin, whatever router I have at home, is really a couple components in one: router, switch, and access point all in one box, and that connects out to my service provider and so forth. So all my devices in my network connect into this probably with just plain old patch cables. Well, that works at home, that's fine, because your distances are typically short and you only have a few connections. But it's not going to work in a commercial building. A commercial building, the structure is going to look more like this. I used a small picture here to get us started. I'm actually going to install in the wall, I'm going to have an outlet here with cabling up through the wall, above the ceiling, and down into my networking closet. And I'm going to repeat that all over my building for users. And the idea is this structure's in the wall, it's not going anywhere, and users can plug and unplug from it at will. Now that seems like a lot of work, because we're so used to this at home. This seems like this is extra equipment, extra expense, just so users can plug and unplug from the network. Well, and here's another example too. Workstations, all this blue cabling is above the ceiling and down into closets, into outlets, that sort of thing. Well, it seems like a lot of work, but let's change gears for just a moment. Think about the electrical wiring in your house. Okay. The electricity, the electrical lines come from the power company down through the meter, down into your basement or the garage, into your circuit breaker box. And then from there, they run wire through the walls up to outlets in your house. So the electricity is distributed around the house. And the purpose of that is that I can walk into my kitchen, plug in my toaster, toast my toast, unplug the toaster, and put it away. That electricity has been distributed over the house for my easy access. The alternative would be I run an extension cord from my toaster down the stairs into an outlet down here that the electric company provided for me. Well, how silly would that be? Okay, so if I think of my commercial building now, I'm not going to run a patch cable from this computer down the hall, down the stairs, into the closet, into the networking closet. That would just be silly. So in a commercial building, here's your electrical wiring like you have in your house. The same idea is applied in a commercial building for data. We distribute the network connectivity all over the building, that way people can plug into it as need be, disconnect from it, and walk away. Or move things around, and this network cabling in the wall is not being interfered, disturbed, moved, touched, unplugged, plugged, etc. All that stuff is in the walls where people cannot mess with it. They can plug their patch cable in here, disconnect their patch cable. It's the same idea as distributing electricity around your house. So, what you use at home for network connectivity, patch cables into my router or Netgear switch on top of my computer desk, that system works fine at home. It does not work in a commercial building. I need a structure like this. And the idea is the same as you have in your house. I'm distributing the network connectivity, just like my electricity. I'm distributing the electrical connections around the house. I'm distributing the network connections around the building for workstations to plug and unplug as need be. So when they start talking structure cabling, that is what they're talking about. They're talking about this structure here, going from a central networking closet, running horizontal cabling out to workstations to an outlet on the wall, and then the workstations use a patch cable to plug and unplug from that network outlet. And there's just two different examples of what it looks like. Same kind of theory, same kind of philosophy as distributing electricity around your house. Okay? Again, here's another example of that. So that is what the structure looks like, network structure looks like in a building. All of these, the total length of the cable that connects all the network devices has a finite length. It can only go so far. If you remember back from 120, copper cabling, twisted pair copper twisted pair copper cabling can only go 100 meters before it has to go into a device like a switch, get regenerated, the signal will get regenerated and sent back on its way. So because of that, I put my telecommunication closets carefully around the building to minimize that distance. And if I look at again a picture like this, I might have a closet per floor, so my cabling distance is limited. It's not going to go the whole way down through the wall, down to the second floor, down to the first floor, down to the basement. That way I can service a whole large area of computers on that floor. And these telecommunications room concentrates all the station cables for that floor, and then combines them together in a switch or something, and then we use other type of cabling to connect between the floors. We'll get to that in a minute. All this cabling on the floor, all this horizontal cabling or home run, is brought back into that closet for that floor. So all these workstations out on this floor, all the horizontal cabling comes into this closet, into this rack, and then the switch here would consolidate that and run probably fiber down between the floors to connect to the other switches. That kind of idea, that's what they're getting at. All this wiring is run in trays or conduits, absolutely. We'll talk about cable support and trays later this semester. All the cabling comes into the closet, gets punched into a patch panel. Again, we'll talk about that later. We'll actually do that too. And then those cable runs get connected into a switch, not going to be a hub, into a switch. And then again, as I showed you, the switches are probably going to be connected together using backbone cabling or fiber between my closets. And to kind of follow right up on that, they say our closets should be located directly above each other. Yeah, and typically fiber is going to be used between my telecommunication rooms for electrical isolation issues. So again, here's a closet on the third floor of my building. All the horizontal cabling comes into the rack here, into a patch panel. We'll do that a little bit later this semester. We connect into a switch, and then the switch using a piece of fiber connects down to maybe the second floor or the whole way down to the first floor, down the other switch. Well, this red cabling in this example here, all fiber, is my backbone cabling. So the backbone cabling is being used to connect my closets together. And again, you'll note that the closets are directly on top of each other. That way I can drill a hole through the floor, put a sleeve there, put a conduit there, and run my cabling between the floors to connect my floors. That's exactly what they're getting at. So my horizontal wiring is that going from the workstations into the telecommunications room. This right here, the blue wiring, that's my horizontal wiring, which you notice is mostly horizontal. My telecommunications room is where all the cabling comes together to be terminated. And again, you can almost think of that as the electrical panel, the breaker box in my house. I bring all the cabling to that for organization purposes, for labeling, for numbering, for organizing, connecting, disconnecting, that sort of thing. That's why I'm doing that. That's what the telecommunications room is for. And then last but not least, the cabling going between my closets is my backbone cabling, this red cabling right here. That's the main pieces of my structure. There's different ways to deal, and wiring considerations first, one floor versus floor to floor, as we showed you here. Multi-floors, we're going to go right on top of each other. So there's my basic structure of my cabling for a commercial building. Like I said, this looks different than what you have for home, but when you're dealing with thousands of connections, this is a way to distribute it and organize it for just those reasons: organizing, troubleshooting, that sort of thing. All right. Some of my cost factors are my LAN topology might indicate that I use certain wiring connections. Yes, if I'm going to use 1,000 base T, or I'm going to do a 1,000 base network, that's going to dictate I use a certain category of cabling, which means I need that type of cabling, that type of connector, that type of outlet, that type of patch panel, that sort of thing. So it's going to kind of dictate what I do, but I still do have some choices on, color of the cable. Do I want to upgrade to another category for future use, that sort of thing? Yeah, of course, absolutely. The second, the LAN wiring methods vary in ability to support higher speeds. So again, as I said, if I install category 5E, that'll handle a certain bandwidth, but if I want to do 10 gig down the road, I might need to install a higher category of cabling. So that's going to affect my cost too. Again, like going to a auto parts store and buying a cheap tire versus a performance tire. A performance tire is going to cost more, but I get the benefit of that on my car. Cornering speeds, blah blah blah. I get that benefit, but it's going to cost more to do it. The third, again, combining all the cable and connections hardware together, that's going to add up. And possibly going with a brand name might cost me more, but again, I might get that assurability that things are going to work, or things connect together and just they perform as they should. They're going to certify better. My percentage of certified cable runs is improved by using blah brand kind of thing. So all that, I kind of have to factor all this together to think about, what do I need now, what do I need in the future, reliability, that sort of thing for my plan. And like I said, this semester we're going to work on a cable plan all semester, so we'll get a taste of what the cost of all these pieces cost. The book then talks about mixing data and phone. Once upon a time, we could take one piece of unshielded twisted pair cabling, has 8 wires inside, and use 4 for data and the other 4 for 2 phone lines, if you will. That was acceptable a long time ago. It's not really acceptable today to mix those two together, because our higher bandwidths, we're starting to use all 8 wires, or using the other wires for power to handle something like powering an IP phone or powering a wireless access point. So once upon a time we would do that. Today it's not recommended, and it's not recommended for the reasons I just said. So yes, it's going to cost more to run 2 data lines to a desk, one for a phone, if you will, and one for a computer, but it's not recommended to put those together for some of the reasons we just mentioned. And there's other discussions we'll have later of, if I pick a good IP phone, the IP phone can plug in the wall and my computer can plug into the IP phone, and I'm still only using one data outlet on the wall. So there's some ways to maximize this to my advantage if I really need to, but it's not recommended to take one unshielded twisted pair cabling, those 8 wires, and split them in half, 4 for data and 4 for phone. It's not acceptable to do that anymore. You wire up all 8 wires and use that as a data run. And if I need a separate phone line for a traditional phone, I use a different outlet jack, a different cable for my phone. Okay, let's see where we are here. I'm going to pause. We'll come back on the next one to continue.